Hello, everyone, and welcome to Inflectra's Level 2 test automation series called Planet Test Automation First Steps. You are joining us for our final webinar in this series, and today's topic is data-driven testing. Today's webinar will be presented by Denis Markadzev, a principal software engineer at Inflectra Corporation. He is one of the creators of RP's test automation platform. He holds a master's degree in computer science and a PhD in mathematics, and has been working in the IT industry for the past 20 years in areas such as compilers, development environments, software verification, and testing. My name is Teresa, and I'll be your moderator today. Before I turn it over to Denis, let's cover a few housekeeping issues. Today's webinar will last for about an hour and will consist of a theoretical part, a practical part, and end with a Q&A session. We ask that you save your questions until that time and use the built-in questions tab to send questions. These will then be read out and answered. Today's webinar will be recorded. In a couple of days, we'll make the webinar recording available on Inflectra's YouTube channel under the playlist called Planet Test Automation First Steps. Please note that this webinar playlist is unlisted for the duration of the webinar series. So prior to February 1st, 2020, you will need to have a direct link to access the recordings to this webinar series. Links to each webinar recording will be emailed to you in a few days after the live webinar. Or you can subscribe to Inflectra's YouTube channel to get notified when new recordings become available. To give you a little more information about the webinar series as a whole, Planet Test Automation First Steps is Inflectra's Level 2 automation webinar series. This series builds on Inflectra's earlier test automation series, Test Automation Demystified. This Level 2 series moves beyond the fundamentals and dives into the major technologies where test automation is used. The 5 webinars will cover UI, desktop, mobile, and API test automation. You can learn more about the series by clicking on the URL shown in your handout and also on the screen here. For those of you not familiar with our test automation webinars, we recommend that you check out our Level 1 series, Test Automation Demystified, available on our YouTube channel. We are also pleased to offer Planet Test Automation First Steps as a certificate course. The series participants are eligible to receive a certificate of completion given that they meet the webinar attendance and quiz requirements. If you wish to get a certificate, you will be asked to take a short quiz after each webinar. To make things easier for you, we will send out a webinar follow-up email that contains all the materials covered in the webinar, including links to each quiz. For a full set of certificate requirements, please refer to the Frequently Asked Questions document linked in your handout. Last but not least, as I mentioned earlier, each webinar in the series has a practical part. We will demonstrate the key practical test automation concepts using Inflectra's own platform, RPs. If you haven't downloaded the tool yet, please visit www.inflectra.com/RPs. Feel free to use Inflectra's 30-day free trial. So with that out of the way, I'll turn it over to our presenter, Denis.
Thank you for the introduction, Teresa. Hello, everyone. So I'm starting. One day, a tester walks into a bar. Do you know this story? So this story is exactly about data-driven testing. So we have a scenario. A tester gets into a bar and orders something. And the tester may get into a bar using different ways, or run, squeeze, jump, or break. And the tester may order something, may order different things. And choosing a way of getting into a bar and in an order, so what tester wants to order, we may run the test scenario many times and test how our bar works under different conditions. So, and this joke just missing one part. So it is missing expected output. So how the bar should work receiving those orders. So what, for example, should happen if someone orders a lizard in a glass? I don't know. So let's look at the more formal diagram of data-driven testing. So we have a data source, and our test reads some input data from it, performs the steps, automates the application, and produces some actual output. Also, the test reads expected output from a data source as well. Then some comparison procedure is executed, and then we get the test result. So it's all pretty simple, but this scheme is pretty powerful and opens a lot of opportunities. So let's look at advantages of data-driven testing. So ability to run the same test using different input data really reveals the power of test automation. So we may do data-driven tests and execute them manually, but it may be not always viable. So for several reasons. So manual execution is too slow, and since it's human operated, it's prone to human errors, for example, input errors, and it is boring as hell. So imagine repeating the same steps using different data again and again. So it's a nightmare. So automated tests run fast, on the contrary, and they never get tired or mistaken. And also, data-driven approach enables separation of data from the test logic. And it makes easier to manage data, and it naturally produces work breakdown. So an automation engineer may work on automation, creation of tests, implementing a sequence of steps, and manual testers and domain experts may work on preparing data so they know how the application should work, what data to input and what data to expect, and they may work on producing those tables of data. Data-driven testing is a powerful thing, but it requires some additional effort. So you may need to acquire some additional knowledge and skills. It is really not a rocket science, but nevertheless, as a test automation engineer, you may need to know something. So you may need to know how to parameterize a test, how to work with different types of files, how to work with spreadsheets and databases from within your test. You may need to learn how to code at some basic level, and you may need to know such techniques as equivalence class testing or boundary values testing or pairwise testing. So we will talk about this in more details a bit later. Okay, so our agenda for today. We will talk about data sources, so where to get data. We will talk about data origin, so what kind of data it can be. We will talk about output of data and comparison of test results and expected outputs. And we will outline some data usage scenarios and talk about data selection, so how to select data for running our data-driven tests. And after that, we will have a demo, and I will show how all this works in rupees. Okay, so let's proceed to data sources. You may store data really in different sources, and it can be a simple text file. So very common formats used nowadays are text file, comma separated values, or XML or JSON files are used a lot. Also, it is a spreadsheet, a relational database. If we are talking about rupees, there is also ability to have a data source right in your RVL spreadsheet. So it is called RVL map. And the right bottom rectangle, generators, it's about generating data you need during execution of your test. So generating data at runtime using some generation code. Okay, so and what is the data origin? So by this I mean that the data may be of different kinds. So it may be a fixed data, so some data that you prepared in advance, added to a spreadsheet, and the same data is used again and again when test is executed. Random data means that some random values are generated every time a test needs some specific data value. There is also a requirement sometimes to have unique data values like global IDs or something like that. So, and the test should be able to generate such values as well. Also, in data-driven testing, we use sequences. So it may be a sequence producing a new value on every test run. So, for example, it may be a transaction ID or invoice number or something like that. So every time you execute your test, this value should be different, should be new, not used by the system before. And of course, encrypted data. So if you are dealing with some sensitive data like passwords, then you need to be able to hide this data from appearing in the reports and be displayed on the screen. Okay, let's go further. So we have data, we executed our test, and we need a way to output our data. And the data may be output into data sources of similar formats as we used for input of the data. So, for example, rupees may output data into text files, comma-separated values files, into Excel spreadsheets. And since it's UI testing, rupees may capture screenshots and produce bitmap files. And we have output of our test, and we have an expected output, so how to compare them. So basically there are two major ways, and I'm sure there are more. But in general, what we use most frequently, direct comparison of values. So for example, we made an input of some data, and the test produces a string, some transaction ID, for example, indicating that transaction completed successfully. And we want to compare it with something. And we may just compare the string with expected value. Or the second way, we may output all their test results into a file and compare this file with some sample output that we stored on the previous run of the test. So we made in rupees, for example, you have a way to compare bitmaps, you have a way to compare spreadsheets. Every cell of a spreadsheet is compared. And if you need comparison of text files or JSON files, XML files, then such comparison can be implemented in two ways. You may either compare those files by content, or you may code some procedure that will read expected and actual output and will compare some parts of those files. Okay, so and next is data usage scenarios. So how we can use our data. And there are many ways how we can use the data. For example, we may use data for data seeding. So what is data seeding? It is initial configuration of the system before we will execute our tests. So if you want to do some invoices, for example, in our CRM system, we need to have customers and we need to have products. And before running those tests, we need to input this data into the system. So, and this is called data seeding. We may need to test our system with valid data. And this is what we should do always. Test with valid data, and sometimes it is also good to test the system with invalid data to see how the system behaves and responds to invalid values, and that the system does not produce some undesirable outcome if invalid data by mistake is inputted into the system. Okay, and the next is data selection. How we select data values from all possible values that we can input into our application. And here we will talk about such techniques as equivalence class testing, boundary value testing, and pairwise testing. So what is equivalence class testing? So imagine that let's return to our bar, and imagine that we have the following rules for operation of our bar. So if someone orders from 1 to 50 beers, then bartender must take the order and process it. If it's more than 51 beers, then the order must be refused. So are you kidding? So, and if any other input is provided, like QWERTY beers or Blizzard in a glass, then such input must be considered as invalid, and some error message should be displayed, like go to sleep and then return and order something meaningful. And what is equivalence class testing? Equivalence class testing means that from each range displayed in this example, we take a value to see how our system behaves under different conditions. So, for example, we may take 10 to test a valid order. We may take 100 to test the case when the order must be refused, and we may use QWERTY to test for invalid output. So in general, this is what equivalence class testing is. There is also boundary value testing. We have the same bar operation rules, and we want to test edge cases or boundary conditions. So for this purpose, we take edge values from our ranges. So we for sure take and try to order 1 beer, 50 beers, 51 beers, and let's try to also order some very big number, like infinity of beers. And it's always good if we are working with numbers to check with 0 and -1. So they're like boundary values, though they do not directly belong to the ranges that we have in our rules. And there is also pairwise testing. I won't be talking about it in many details, but I will say from what observation this type of testing occurred. So the observation was that most of bugs in systems are caused by combination of at most 2 factors or 2 parameters. And For example, imagine that we have 4 parameters in our system, and each parameter may have three inputs. And in this case, if we will take all the combinations, we will have 3 by 3 by 3, 27 combinations. But if we will generate an all pairs combinations that will contain all the different pairs of parameter combinations, this number will be significantly smaller. And you may learn more about this type of testing on the website, and the link is presented on the screen right now. Okay, so the demo. Now I will show how all this works and how you can apply data-driven testing in RUPIs. For the demonstration, I will be using OpenMRS application. If you attended the previous webinar on the REST and SOAP testing, you're familiar with this application. You may use the online version of it, or you may download the standalone package. It's a single file, and you may unzip it. And if you have Java installed on your machine, you just double click and you have the system running on your local machine. And the sample framework that I will be showing you right now, it is already on GitHub. So you may scan the QR code or type this link directly into your browser address bar, and you will get to this framework. Okay, so let me show you what this framework shows. Okay, where is my screen? Okay, here it is. I have this framework opened in RUPIs. This framework contains a few subtests that demonstrate different aspects of data-driven testing in RUPIs. So, and let's look at them in more details. Here is the data sources subtest. And it is all the subtests are RVL based, so they're using codeless techniques. So here I will open main RVL for data sources. And this main RVL contains several sheets showcasing how you may read data from different data sources. So this is how you may read the text file. So we have a global file object with all the file operations, and you may read the file and you will get contents, and you may either print it to the report or you may compare it with some expected value. CSV files, actually CSV files and spreadsheet files are treated the same in RUPIs. So here I have a data object for a CSV file. The CSV file is on the disk. So it is not, it is here. So this is the data CSV file. And we have a data object in the object tree for this file. So data objects are inside spreadsheets node in the object tree. And here it is. When you add a spreadsheet to your RUPIs test, the data object is usually created automatically. If you don't see it in the list of spreadsheets, you may right-click a spreadsheet and choose Create Data Object, and data object will appear in your object tree. So when you have it, you may use many actions to operate this spreadsheet. You may read columns, rows, and you may even write data into the spreadsheet. So here in this example, we have a loop in RUPIs, and it performs sequential iteration through all the rows of this spreadsheet. read some cells from specific columns. So actually, in this spreadsheet, we have two columns. So let's see it here. We have column word and we have column language. And we read those cells and put them to the report. Okay, as for XML files, if you need reading them, then you need to code this. And we have some sample function here, reading XML file. So let's go to the end of user.js file. So basically, it is using Microsoft XML DOM ActiveX object. And using it, you may load XML and you may query it using XPath and get the values. So if you need XML processing, then you will need to code it. Okay, JSON file. So Rapis has a global object, and this global object has set property and get property actions. And those actions are using config JSON file that is created by Rapis automatically, and this config JSON file is in JSON format. So if you want to store something in JSON, then you may use global set property and get property actions. Excel file is the same as CSV file, so same way of reading. We may open it here, and Rapis has built-in Excel editor, and you may edit this file right in Rapis. Okay, RVL map means that you may define your table right within your code. So this is very convenient when you are just developing your test. And you may read, iterate through this map. So this RVL map is called dictionary. And we iterate through this dictionary in a loop and are reading some columns of this dictionary. Okay, and RVL map also may bind to an external spreadsheet and may be used in the same way as RVL map with data defined inside Rapis RVL file. Okay, the database. Rapis may read data from relational databases, and if those databases have ODBC protocol supported, and most of them have this protocol supported, then Rapis is able to read this data. So let's see here. We have, in this example, we are reading data from some public database. It's my SQL database with some DNA, RNA information. And to read data from the database, we need to use doAttach action. We need to pass connection string and SQL statement to execute. So with this statement, we select some values from a specific table. And then when we have this data read from the database, we may iterate through this data in a loop, just like we did for the spreadsheet. And the last way is generator. We have some generators ready for you. And if you will navigate this link, you will get to GitHub repository that contains some generators. So let's actually do this. Navigate to this repository. And it contains some code in user.js file that you just need to copy to your test. And when you have this code copied, you may use some patterns to generate random data. like random numbers or dates, or even some random real-life looking contact details. And you may use those generators in JavaScript and in RVL as well. So here is the example how to get the contact information. I'm using this technique in some more sophisticated tests that I will show a bit later. So I will close this for now. Okay, so for example, here we are calling getData function, and we want to generate some data in the format, so year, month, and date, and we print this information to the report. Okay, this is about data sources. Then data origin, go into main RVL. So here we have a showcase of how to iterate data in different ways. Fixed is we are reading data from either RVL map or a spreadsheet, and we may iterate data in different ways. So we may iterate it sequentially by calling doSequential of a spreadsheet object, or by simply looping through RVL map, like here, or we may iterate through the table, through our data in a random way. So here we have a loop from 1 to 10, so it will have 10 iterations. And at the beginning of each loop, we are just calling doRandom action that sets the pointer to a random row in the table. So if we will execute this, we will get days of week in a random order. Okay, on the random tab, we have the showcase of generating the random data using data generator available on GitHub. I already showed this. Unique. Here we may use the same getData function that may generate some unique data according to global UID format. So you may find it. The list of formats is available here in the table. So here it is. A sequence. So the best way to produce a sequence is to use global get property and set property. So you may read a property, and if it is not yet in JSON config JSON file, you may provide default value for this property. So what these lines do, they read invoice number property and place the result into invoice no variable, and then we use it. And then we increment this variable by 1 and store it inside config JSON back. So next time we execute the test, we get the next number, and it is never repeating. Okay, on the encrypted tab, we have a showcase of how you may use hidden password data. So you may encrypt the password with rupees using global doEncrypt, and then encrypted value may be used in your test. So looking into this value, nobody will figure out what is the password actually. Okay, so next is data output. Data output is here, and it shows how you can write different types of files. You may write a text file with file write. You may create and write a CSV file. So here, what we do, we delete the file if it is already on disk. Here is the variable that contains the file name. Then we create a spreadsheet. We add columns that we need, and then we add the row and set cells to values that we need. And when we edit all the data to the spreadsheet that we need, so it may be an output of the system, we need to call spreadsheet do save, and after that spreadsheet appears on disk. And for example, if we have some expected spreadsheet with expected output, and we may use spreadsheet do compare action that will compare two spreadsheets. So it will find the columns with the same names and will compare the sales for those columns. So this is very, very convenient. The same API is used for Excel files. So the same spreadsheet object and same actions. For XML file, you need to use Microsoft XML DOM ActiveX object and code output yourself. JSON file, it's global set property. And there is also a bitmap file. So with for objects that repeat captures during recording and that are in the object tree, all of them have get bitmap action, and this get bitmap action gets the snapshot of this element displayed on the screen. So, and it's possible to store the image of an element during recording. So when you use verify, and during playback, you may have an assertion that compares the actual bitmap that we have during playback and the expected bitmap. Okay, so these are basic operations. So we know how to read data, how to output it, compare it, and how to have this data generated during execution. And let's now see a couple of real-life scenarios implemented for OpenMRS application. So here we have subtests. Let's go to Files View, and we have default logins subtest that reads the data from this data XLS. So it has a sheet named default logins, and it has a table with username, password. And what this default logins test does is it reads the data from this spreadsheet and then executes the login subtest and passes username and password to this subtest, and then performs logout. So if we look at the login subtest, it has the parameters defined in the preamble in the beginning, and then just opens the application and inputs username, password, and presses the button. So it's pretty simple. So with this subtest, we default logins, we may check that all logins that should be in the system and should work are okay. The next example is check dashboard tiles. So this is a more sophisticated one, and what it does is, so let's look at the data first. So here we have a table that shows what modules should be available for different kinds of users. So when admin is logged into the system, this type of user must see all of the available modules in the system, and the modules are limited for less privileged users like clerk, nurse, or doctor. So, and in the intersection of the module name and the username, we have why if this module should be available, and have nothing if it should not be available. So let's look at the code RVL of this test. So it reads the data. Here is the map with available modules. And here is the procedure that in a loop goes through all the lines of this table and checks the result. So, and the last one is register patient. So what this one does? So this one uses data generator to generate fake contact record, and using it and using different generators, it produces data that is inputted into the system. So here, the data that we generated, we input into the system. So let me now execute all these tests so you will see how it works in action. So actually, all the subtests are executed from the main RVL. So all of them are linked here. And I will now execute them. And then we will look at the report. So I will be finalizing soon. So you may start thinking about questions. And if you have questions, write them into relevant section of GoToWebinar. So checking default logins in the system. Works so far. And checking the tiles. So something works. So now we log using different usernames and check available modules. So they are those gray rectangle boxes with different icons. So it works pretty fast. So imagine doing this manually. It will be really boring. So now the next, register patient. So it generates some random data, random names and second names and birth date. And it is added to the system and deleted from the system immediately. So, and we do this in a loop. So data-driven testing is a good thing. Just one warning. So data-driven testing provides a temptation for you to create a lot of data and have huge data files and execute your test with all the various combinations using pairwise testing and boundary level testing. So this is all good in theory, but always remember that you are doing UI testing, which is fragile and rather slow compared to unit testing, for example. Of course, faster than manual testing, but slower than unit testing. So try to limit the data that you're using for execution. So try to not generate thousands of different combinations to run your test. So it may be hard later to debug and find out what is wrong. Either the system behaves incorrectly or there is a problem with the test. And one advice when you're doing data-driven testing, it is advised to have first run a test set that checks that system works in general. So it's operational, everything all seems to be working, and only then run data-driven tests that run again and again the same scenario with different data. Okay, so it seems that I showed what I wanted to show, and we are opening for questions. So thank you for attention.
Thank you so much, Denis, for that presentation. That was fantastic. For the Q&A session, I'd like to invite our colleague Alexi to join us. Alexi, are you on the line?
Yes. Hi, Teresa. Hi, Denis. Great presentation. We have a couple of questions. And first of them is, do we need to have Excel installed to work with spreadsheets?
Okay, good question. Actually, no, there is no need to install Excel on the machine. And for example, my demo host does not have Excel installed, and Rupis has built-in editor for spreadsheets, and you may create spreadsheets right from Rupis. And also, Rupis does not need Excel driver to read and write spreadsheets. Do we have more questions?
Okay, yeah, we have one more. Can Rupis connect to MySQL database?
Okay, so yes, Rupis may connect, and if you are looking for some specific steps how to connect Rupis to MySQL, you may go to Inflectra knowledge base and make a search for MySQL, or better to make a search even for ODBC, and you will get the articles that explain how to connect to different types of databases. And you may open this knowledge base article, and you will see that to read data from MySQL, you need to install MySQL driver on the machine. And after this is done, you may use the connection string into the following format. And
so this driver is from MySQL, right? And it's like free.
Yeah. So you may see that the link contains mysql.com. So this is what they provide for Windows.
Okay. And we have one more question actually. And the question is, how do I run a test with specific data row? I think they mean data row in the map, probably.
Yeah, sure. So if we have a spreadsheet and it has a lot of data rows, so imagine that this is real life situation when you run and a specific row, the test fails, and then you want to rerun with a specific row. So if you are dealing with RVL maps, so let's go to data sources. If we are dealing with RVL maps, then, so where it is, Excel. Oh, no, it was in data origin, I think. In fixed section. So if we are dealing with map, and we are iterating through the map to run our test with a specific row, we may just quickly type this in the first column of our RVL, and the loop will grab only this row and will execute just one iteration. And if we are talking about spreadsheet object, then to run something with a specific row, we may use So this object has days of week. It has do move to must have do move to row. So you may specify the row number, and your loop will start with this row number. So I hope it helps. Do we have more questions, Alexei?
Okay, so we run out of questions for now.
Okay, so thanks everyone for listening. So it was the last webinar in this series. So hopefully we will see you next year in our next webinar series that will be announced later. So Happy New Year and Merry Christmas from my side. So Teresa.
Thanks again, Dennis, for today's presentation, and to you both, Alexei and Dennis, for a fantastic webinar series. We appreciate that. To our attendees, we'll send out an email in a couple of days with a link to the recording for this webinar. This concludes today's session. Thanks again to Alexei and Dennis.
Thank you, Teresa. Thanks, everyone.
Thank you. Thanks, everyone.
Thanks for watching.